Good morning, everyone. This is a little low, but to stand. I'm going to talk about a study that we did on Florida panthers down in Southwest Florida, predicting their movements farther north, expanding their population, and trying to identify road location, crossing locations. So first, a little background. So Florida Panther is a cousin to the mountain lions that Reed was talking about, but it's an endangered population because it's restricted primarily to the southwest corner of the peninsula in Florida. There's only about 175 individuals currently in the wild. One of the reasons it's isolated is there's a barrier, the Caloosahatchee River, that separates the central and northern part of the peninsula from the southern part. And that's a significant barrier. We haven't had a female cross that since 1973, so a long time. And the population, there's been recovery methods going on, which has increased the number. So back in the 70s, it was about 25 animals, so it was very small. But now it's come back. And then the first female crossed the river in 2016. And so that was a big step towards recovery of the panther. One of the things and this is what kind of pushed this project forward. So it was sort of a surprise. So the Fish and Wildlife Service was very interested in now trying to predict where panthers are going to go in South Central Florida, and also what kind of conflicts that they might encounter. And looking at roads and traffic is one of the big ones, since that's the primary factor in mortality. So last year was a record year of 30 animals. We only had, I think 2016, there was 35 killed on highways, but that's an unsustainable number with a small population like that. Average of 25 a year gets killed on our roads. So we've got to address that problem if we want to push forward recovery of the population. This map shows general range of the panther right now. This is the Caloosahatchee River right here. And so you can see that a far majority of them stay down in that core range. There are males that have explored north of the river. They're more willing to cross the river and also cross roadways. So we have a little bit of data for those that were collared, and some panther sighting data up there that I'll explain later, that was sort of used in validation of the model. But our focus really is on predicting panther movements and natural range expansion within the South Central Florida region. Okay, so the primary modeling we used to start out with was least cost path and corridor models. And so that's based on really two factors, determining on where their movements might go. Availability of land cover types that panthers use, as well as the distance between the target locations that the pathways and corridors are plotted. This was done in ArcGIS. And we used two data layers primarily: the most recent land cover data that was available from the Florida Fish and Wildlife Conservation Commission, and then a panther habitat assessment methodology that was developed in 2012 based on panther GPS collar data, identifying land cover type preferences of panthers. And so that we used that to establish our coefficients for doing the model. There's a three-step process with the model. First, the land cover data is much more finely resolute. So 192 classes for the study area. And we had to whittle those down to match what the habitat methodology data was showing. So they didn't, come up and rate them for that many different classes, much more generalized. So we whittled that down to 17 classes, which are showing in the table over here. The places that panthers used the most were forested habitats, forested wetlands, pinelands, hardwood forests. And then you get down sort of in the middle of the table here, more rural lands, agricultural matrix, And then the higher cost areas that Panthers do use on occasion, more urban, intensified agricultural areas. And then we artificially put high coefficients in for very strong barriers, such as roads and open water areas, high intensity built environment areas. So after we did that, created a cost surface using 10-meter resolution, and then used the inverse value of these values. So the model is actually a range of between 0 and 1. Okay, so that's what went into the cost surface. Then we had to plot between the target areas. So we identified 34 target areas within the Florida Ecological Greenways Network. These include larger conservation reserve areas, and then also smaller stepping stone type conservation areas that would serve to assist in panthers getting more longer distances across the landscape. We used two different things. First was a least cost path to plot lines between the target locations. And then we used the corridor tool in ArcGIS, which basically takes two cost distance rasters, one associated with the destination and one with the source area, and it combines those, and then it gives you a layer of multiple classes. We sliced this into seven graduated classes using Jenks natural breaks, and then chose the 3 lowest classes to represent primary, secondary, and tertiary corridors. That's the different table of different target locations. I won't go into that. And then this is what the results looks like. So the purple lines are the least cost paths. And then the green is the primary, light blue is the secondary corridor, and yellow is the tertiary. So basically what you ended up with is 76 pathways between 34 target areas. We also took some general metrics of this. So average length 30 miles, minimum length 2.6, and the longest corridor is 93.3 miles. The corridor analysis included 54 corridors between the 34 target areas. And you might notice in many cases, the secondary and tertiary really act as buffers to the primary. But the things that we're really interested in is these alternative linkages that are provided. So it also provided some of that to look at options when we're planning for connections between the conservation areas, particularly in this Florida landscape, which is probably quite a bit different than the Olympic Peninsula. This is highly urbanized, mosaic, as well as a mix of agriculture and natural land. So connections through here can get severed with development. So it's important to identify alternative connections to try to complete a connected network of conservation areas. All right, so 86% of the corridors overlap with existing conservation lands or the FEGN, the Florida Ecological Greenways Network. The primary level corridors, 94% in existing conservation lands or FEGN. Now, let's see, I got it. Okay, so I switched the maps here now. So we also then started to look at, okay, where do these intersect with roadways? And so 479 intersections of the least cost paths act as potential conflict points on roads. And then we also looked at what are potential opportunities that are already in place out there in the landscape. So 179 of these are potential opportunities for connectivity with existing bridges within a half a mile. So even though 479 is a big number, we can chop that down some by utilizing existing structures. Evaluating performance of the models. One of the issues we had to deal with here is there's very little data available on panther use of the South Central Florida landscape. So only a handful of collared panthers have been recorded north of the river, and only 2 of those were on GPS collars. The rest were old VHF collars where they maybe only collected a location 2 to 3 times a month. So it's not very fine scale data, so it's really hard to compare the model to some of this data. And particularly with the GPS data, those were collared males, and they're in search of not only setting up home ranges, but finding females. And so they wander through the landscape rather randomly, searching for these resources. And so it's also not really reliable for predicting exactly where they'll go. If you had an established population up there, it would change. So it's not ideal data to compare this to. We also use bear telemetry data, mainly because the habitat suitability for them and panthers is very similar. And we used that to try to increase the amount of data points we had up there to look at validation. Obviously, it matched a little better with the bear data, but that's because there's existing populations of black bears in this area, unlike the absence of populations of panthers. Road mortality matched up pretty well, as confirmed sightings. Oh, sorry, forgot to advance the slides. So that's the bear telemetry data. So you can see only a few of those, but those were GPS. And then this is the mortality data. Not a lot of data here. This is another thing. There's very little data on panthers in this area, as I mentioned before. So not that much road mortality or sighting data. Okay, so that model's been used by the Fish and Wildlife Service for planning purposes, identifying crossing locations, and also in identifying priority areas for habitat protection. But we wanted to evaluate this using a different method as well. And so we used the current flow model similar to what Reed was talking about. And we found that there's many similarities. I only isolated two categories from the model here, which is more intensified flow. So, you know, good connectivity, but in a area where there's a fairly strong resistance category. So either urbanization or agricultural. And then the channelized flow in the red there was where you have really high flow, but it's in bottleneck areas, so it's very restricted movement. But it still matches up fairly well with the corridor model, but it goes a little beyond that and actually identifies some alternative locations too for other connections. And so we're going to work with this a little bit more, changing values and things, and see if we can combine multiple methods to give a better product to the Fish and Wildlife Service for alternatives for improving connectivity in the landscape. And I think that's it for me. We got credits on. So this was done through the Florida Panther Recovery Implementation Team, sub-team on transportation, and a number of people from diverse, a lot of different agency people, some NGOs, and myself, I was on this team. We collectively supported and then generated this product. And then if you got questions, I've got my email up there on the models, planning and policy inquiries, David Schindel with Fish and Wildlife Service, and Katasha Cornwell with FDOT. Data is available also on the Florida Geographic Data Library. So thanks very much.
We have plenty of time for questions.
Yeah, go ahead, Jason.
Yeah, well, first, Dan, is that the email address?
Oh, that's an old one, sorry. I thought I corrected that. Yeah, no, that's my old email. So I'm now at the University of Florida. So it's djs3@ufl.edu.
Dan, I wanted to ask, if you can characterize the difference between primary, secondary, and tertiary. I mean, is there a substantial difference in terms of the value between each of those response pathway actually?
Okay, so the question was, can you describe the differences between the primary, secondary, and tertiary corridor areas? So yeah, the least cost path is finding the best habitat for the shortest distance. That's kind of the bottom line of how it works. And so those primaries are the most ideal connection between any of the target areas. And so as you go out to secondary and tertiary, it adds in more marginal habitat types and also more fragmentation as well. So it's not as high a quality as in the primary. And I don't know if I can go back to one of the maps maybe to show. Yeah, here we go. So there are wider areas of the green too. So that kind of shows you that some areas have larger, more consolidated connections where the quality of habitat's better. And then you have much narrower areas. So where, like in some of these, I've got the cost path line is totally covering up the green of the primary. So yeah, so in those real channelized areas like that, you may not get a lot of differences. So it's mainly a difference of quality of habitat and fragmentation. In the middle.
Yeah, I got a question. So, what about how you fold this into the analysis phase? What about public acceptance?
You mean okay, so the question is about public acceptance of, I guess, protecting these areas that have been identified in the models. So I didn't have time to go into it in great depth, but so you've got the Florida Ecological Greenways Network. That's a statewide model of protected areas and connecting corridors, so ecological network. But in 2021, is that right? The Florida Wildlife Corridor Act passed through the legislature and created a statewide initiative to not only protect these lands, but actually to form groups to help complete the corridor and either protect them as fee simple lands, purchase them and put them into conservation, or also conservation easements. So there's been a big effort to actually bring this to reality. So it's a big undertaking. So the Florida Wildlife Corridor is about 16 million acres in Florida, and only about half of that is protected. So there's a long ways to go with it, but it's an ambitious effort, but it has a lot of support politically and publicly. Yes.
You included roads for the really high distance.
Yeah. Yeah.
If you took roads out, you said just to correct the average, you get a substantially different pathway set of these cost paths. Can that tell you something about where the road is the rest?
Well, we tried, I don't know that I ever set the roads to 0, but I did reduce the resistance on it, and it did change the model considerably, where they would actually go through much more higher risk areas. So the biggest thing about the roads and the reason we elevated the value so high is because these models are, it's a 10-meter pixel resolution. So some roads, in fact, this is getting now into more of the details that I didn't have time to talk about before. We actually had to buffer the roads to make it multiple pixels because the model would cheat. And so if you had a road that's at a diagonal, for instance, then when you really zoom into this, it looks like a checkerboard, right? Well, the model would cheat and just cut through one of those where you've just got a point of the road coming together. So we had to increase the value and also widen the roads in the model to get them not to find points like that where a Panther wouldn't be looking at that. It doesn't see the landscape as a checkerboard. So anyways, it's trying to make this a more realistic representation. Yeah.
Thanks.
Because, was actually in, North of production, and I knew the mortality factor. Trying to cross the road once one would be killed, and I went to those locations. And it turns out they were like my mom, they were following a parent base, and there's culverts there.
Yeah.
So one thing that Panthers know to be pesky, they can be on the road sometimes because of that inland spots. So the culverts are actually very helpful in the water.
Those were factored into the model too. Existing underpasses and fences.
Sorry, I'm
So-
keeping us on.
That's fine, no problem. You can ask me more.